In this lecture, we're using Time.deltaTime and a variable to make our player move at a good speed and not too quickly and not too slowly. Let's get started. A whole bunch of game development is problem and solution. What's our problem at the moment? Our object is moving really fast. And I guarantee if I play on this computer versus if I play on my old crappy laptop, it'll move at a different speed. And that's no good. We need to have our player move consistently. And we do that using Time.deltaTime. Let me give you a little bit more context here. I'm going to make my game window as big as I can so that I finally see stats on within the top of my game window here. If I click on that and click on play, you can see the frames per second that I'm getting in my game. It's around 150 frames per second. Yours might not say that. And it might be that sometimes it's 130 as it was just there and sometimes 160. And if I'm calculating a whole bunch of particle effects and explosions and enemies, it might drop down to say 70 frames per second. So we can't rely upon our computer to have a consistent frame rate. It's going to be variable. So therefore we need to have our player consistent and understand a consistent frame rate, even if our computer is not trying to give us a consistent frame rate. And frame rate is important because update is being calculated each frame. So each frame we're trying to move our character based upon whether we're pushing to the right or pushing left, up, down, and it's moving it one on the X value or another one, another one, another one, and it'll move it a lot further and a lot faster if we're calculating update a lot more. So let's give a little bit more context to that and talk about using Time.deltaTime. So Time.deltaTime can tell us how long each frame took to execute. That's what it's doing. So time is the class we're tapping into. The clever folks at Unity have created a delta time value that we can access. And when we multiply something by Time.deltaTime, it makes our game frame rate independent. So in other words, the game behaves the same on a fast computer as it does on my slow, crappy laptop. Just to be really clear what's going on here, if we've got a slow computer and a fast computer, I've just rounded the numbers to 10 and to 100. This is the frames per second that we would see on those computers. So on our slow computer, if we have 10 frames per second, what that means is each frame is taking 0.1 second to execute. So 0.1 plus 0.1 plus 0.1, we have 10 0.1s happening each second. If it's a fast computer, it might be getting 100 frames per second, in which case each frame is taking 0.01 of a second. So each 0.01 second, there's another frame, another frame, another frame. And after 100 of those have gone by, we've reached our 1 second mark. So to write it out in terms of moving our player 1 unit to the left, we would say 1 unit to the left times 10 frames per second times 0.1, which is the duration of the frame, equals 1. You don't need to worry about this formula so much. I just want to show you that Time.deltaTime is this number here that's being calculated constantly by the computer and it's making sure it's moving the right distance. So we'll jump back into our code and have a look at this. We've currently got input.getAxis horizontal, and what this is giving us is a number from -1 to 1. -1 is we're pushing left all the way, and +1 is we're pushing right all the way, and 0 if we're not pushing on either of those. And then we're putting that into here, so if we're pushing all the way to the right, it's going to be moving 1 whole unit per frame, and that's too quick for us. So what we'll do is multiply input.getAxis horizontal, we'll multiply, which is the asterisk, that's shift and then the 8 key on your keyboard, by Time.deltaTime. And while we're here, we'll do the same for our Z or Z value. We'll multiply that Time.deltaTime. Save and see what the result is back over in Unity. Let's click play. And then as we move around, oh yeah, we're not flying off the screen, but whew, you know what? It's going pretty slow now. We need a way of tuning this. So, let's make it a bit faster, or a bit slower, a bit faster. We need a way of tuning it. And we're going to do that with a variable that we multiply to our equation here. So we can make it a little bit bigger, a little bit faster. And I think you're ready for that as a challenge. So the objective is to multiply by a speed variable by creating a new variable called move speed. And the value of move speed does not need to update each frame. There's a hint for you. We set it once and then we leave it. Also make it available in the inspector. There's another clue for you. We've done that in the past. And then multiply your X value and Z value by move speed so that we get that right number being placed in our transform.translate. There's your challenge. Take that on. I'll see you back here when you're done. So we don't need to change each frame, therefore we put it at the top of our class. We will add a float and we'll call this move speed as I outlined, and I will initialize this. So we've declared our variable, and now we initialize the variable at, I'll make it 10f because I don't know how fast it needs to go. I'll just make it 10 as a round number. Then we needed to make it available in the inspector, and to do that we serialize. So square bracket, serialize field. Good, job done there. Now we need to multiply our little formula down here by our movement speed. So at the end of our float x value, I'll hit asterisk to multiply by move speed. We'll do the same for our z or z value. Maybe I'll stop saying z or z. I'll just say z from now on if that's okay with you. You know what I mean when I say z. You're not going to be all confused. Okay, so we've created all that. I'm going to save. Back over into Unity. Make the game window a little bit bigger. Click on Dodgy the Player so I can see. Here's my move speed value. Click on play, and that feels pretty good. Yeah, moving around in the world at a good speed. If I wanted it quicker, I could say, hey, what happens if I put it up to 23? Oh, you know, that's quick. If I want a really quick game, that's good. And what happens if I put it down to 3? Maybe a little bit slow, but that's good if you want to get more slow precision. For now, I'll just leave it at 10 until I've got more of my game in there, and then I might tune it a little bit more. So there we go. We've got a much better movement system in our game now, and it's going at the speed we'd like it to, with some control over being able to make it faster or slower. Great work. I'll see you in the next lecture.